What if we have a difference of squares with variables in our exponents? Yes, you can have variables in your exponents. So what if you're given x to the 2t minus 25? Do not let this scare you. That's all it's trying to do. What you want to do is think of it this way. Ignore the variable t. Yeah, really. So what you're going to have is x squared minus 25. You know how to work that. All right, what's next? Factor as usual. Okay, I can do that, not a problem. So I changed a 25 to a 5 squared. Now everything has a power of 2. Perfect, that looks familiar. So that's x minus 5 times x plus 5. So we factored it. And I know what you're saying. Yeah, but what about the t? There's a t in there. There was a 2t. It is really this easy. Are you ready? You sure? You're going to put in the t as an exponent on the x. That's it. Wherever there's an x, put the t as its exponent. You get x to the t minus 5, x to the t plus 5. And that's your final answer. Now, I know what you're saying, but we had 2t. Yeah, but that's t plus t. 1t goes here, 1t goes here. What's an even split of 2? 1. So I got one of each on the x. And that's it. Ignore the variable and put it in as an afterthought later on. That's it. We have a new example, b to the 2x minus 36. All right. Ignoring the x for a second, you can see that that's b squared minus 36. What I'm going to do is I'm going to ignore the x for a second. So I got b squared minus 36. And I changed the 36 so it is a power of 2. Perfect. Now this looks like something that we've done before. That's a difference of squares. b minus 6 times b plus 6. Good to go. Okay, but what about the 2x? Well, I had 2 x's, so what's half of 2? 1, so each one gets an x as a power. That's it. One x goes on one b, and another x goes on the other b. That's it. It only looks confusing, and it looks hard, but it's really not. Work without it, then put it in later. All right, let's kick it up just a little bit more. What if I give you 25t to the 2d minus 81c to the 2m? So now I got variables, both of them with exponents with variables in it, and then I've got numbers for everything as well. All right, go really slow. Ignore the d and break everything down in terms of powers of 2. 25 is 5 squared, then I have t squared. Again, ignore the d. 81 is 9 squared. I have c to the 2m, ignore the m. This is just c squared. Do a difference of squares. 5t minus 9c, 5t plus 9c. So the next thing we're going to do is put in the variables. The t gets a d exponent, and the c gets an m exponent. Again, there were 2 m's and 2 d's. So what's an even split of 2? 1 d for each t, 1 m for each c. And that's it. Now I can't let go of exponents just yet. What happens if I have negative exponents for difference of squares? Well, in math, there is really no such thing as negative exponents. We need to rewrite these. How do we do that? Well, understand this is 49 over 1, and this is 81 over 1, and this is d over 1. To be very clear, let's understand something. This exponent of negative 2 is only attached to the d. It is not attached to the 81. The 81 has its own power of 1 here. So this negative 2 only gets attached to the thing directly in front of it, in this case just the d. The 49 has the negative m, so this 49 is going to have to deal with this exponent. When it comes to negative exponents, the only ones that are negative is the d and the 49. To make these a positive exponent, you notice that again that I put it over 1, even the 81. The 81 is not going to go anywhere because it has a positive exponent. It will not move. Yes, we're going to move these exponents. Anything with a negative exponent is now going to be moved to the opposite place of where it's at. It's going to be moved to the denominator. By moving it to the denominator, it makes the exponent positive. So now I have 1 over 49 to the m minus 81 stayed put in the numerator, but only the d moved because it had a negative exponent, so it moved to the denominator. This now looks like something that we did on the difference of squares video. And I know this looks a little weird right now because this is 49 to the m. That's a little weird, but hang on a second. (49) is 7 squared. The m pushed back a little bit, it's on the outside of the parentheses. 81 we know is 9 squared, and d we know still as d squared. Nothing changed with this. We're concentrating on this guy right here, 7 to the 2 to the m. We're going to rewrite this denominator. This parentheses was here only so that we could understand the 49 is really 7 squared. The parentheses here separated it from the m, but what this means is this is 2 times m. So I don't need the parentheses anymore. This is 7 to the 2 times m. This is the only variable in our exponent. From here again, this looks like the video for difference of squares. Rewrite this whole thing using a difference of squares, ignoring the m. This is nothing more than 1 over 7 minus 9 over d times 1 over 7 plus 9 over d. We had 2 m's. Let's go ahead and do an even split of that. Even split of 2 is 1, so each 7 is going to have an m attached to it as its power. So what if we have higher powers? My answer to that is don't worry about it. First thing that I'm going to do is kind of write it like a difference of squares. This is h to the 4t minus 5 squared. I want you to pretend you have h squared minus 5 squared. If we factor that, we would get h minus 5 times h plus 5. The 5's are good to go because we were given a 25, that's 5 squared, even split. Here's what we're going to do next. What is an even split of 4? Hopefully you're saying 2 and 2. Alright, so let's do that. This would be h to the 2 minus 5, h to the 2 plus 5. So far, so good. But there was a t. Now what you're going to do is place your t on the h squared, meaning h to the 2t minus 5, h to the 2t plus 5. And you're done. This can no longer be factored because this has a power of 1 to it. This guy's a power of 1 to it. The only way I could go any further is if this 5 had a power of 2, and it does not. That's how I know I'm done. You have a 2 here, you've got a 1 here. I can't go any further. This would have to be a 2 in order for me to move on. That's why we're done. Alright, let's try a new example. This is 64 times m to the 4a minus 81 times v to the 10b. Yeah, that's a b. Okay. So first thing that I'm going to do, I'm going to make sure I'm going to make sure that all my numbers get broken down. 64 is 8 squared. This is m to the 4a still, minus 81 is 9 squared, v to the 10v. Good to go. What I'm going to do, one more time, is pretend like this is a difference of squares. This is 8m minus 9v, 8m plus 9v. Again, in my head, I'm doing this. That's all I'm doing. I rewrote it like this as a difference of squares. Go to the pattern that you know. What I'm going to do next is I'm going to deal with the 10. Half of 10, or an even split of 10, is 5 and 5. An even split of 4 is 2 and 2. So the m I split into 2 and 2. The v I split into 5 and 5. My next step then is to put in the correct variables in my exponents. The m's had the a, and the v's had the b's. Again, you always put it in as an afterthought. That's it. Want to try it again? I have another one. All right, let's look at this new example. I have 144 v to the 100t minus 196 u to the 60c. Whatever, it doesn't matter. I'm going to deal with my numbers first. I have 144 is 12 squared. The 196 is 14 squared. I did nothing with my variables just yet. The good news is they're both even, so that is a difference of squares. What I'm going to do is pretend that this is 12 squared v squared minus 14 squared u squared. And that gives me this right here, the difference of squares. So that does not bother me none. Again, go back to the pattern that you know. Now that I have it in terms of difference of squares, we can go straight to the following. What is half of 100? 50. Well, it had a t on it, so put 50t and 50t. Half of 60 is 30, so put 30c and 30c, and you're done. If you want to put in an extra step, you can, but that was the faster way to do it. It just depends on how comfortable you feel with doing these. Pretend this is a difference of squares. I want you to I can spell.